Hello! Anyways, in this video we're going to talk about sections 6-4. And you know what? And then I'll do 6-5 and 6-6 together because they're sort of related. So this video is just 6-4. Alright, 6-4 is basic matrix operations. Now, in the sections previous to the 6-2, 6-3, we did a lot of crazy stuff with operations. You did your Gauss-Jordan. I should say systems of equations. You did your Gauss-Jordan. Gauss-Jordan will come back in 6-5, 6-6, and then again all in chapter 7. So it doesn't go away, unfortunately. It's my favorite thing, I'm sorry. But 6-4 is a break from the craziness, and it's really not that bad. Notationally, it looks awful, but in practice, it's actually quite nice. So we'll start off with matrix addition. So in mathematics, anytime you define something new, like logarithms that we talked about earlier, you had to talk about what does it mean to add logs, subtract logs, yada yada. If we were in a STEM class, you'd have to talk about imaginary numbers. What does it mean to add imaginary numbers, subtract them, multiply them, things like that? Well, matrices are their own little beast. So what does it mean to add matrices, subtract them, multiply them, divide them? Can you divide? You can't. So that's what this section is all about, is how do matrices interact with each other? So the first one there, let's zoom out on this. Matrix addition. The sum of two m by n matrices. Remember, the first number, m, is the number of rows. The second number, n, is the number of columns. A and B is the m by n matrix A plus B, which is found by adding corresponding entries of matrices A and B. And then the difference, only two changes there. A minus B is the name of it, and it's found by subtracting the corresponding entries. So what's built into this definition is what must be true to add or subtract matrices, and that is they must be the same size. Meaning they must have the same number of rows and number of columns. So if you add two m by n matrices, you get another m by n matrix. If you subtract two m by n matrices, you get an m by n matrix. That's what this says in English. So they must be the same size. That's not going to be true for multiplication. Spoiler. All right, so for example, once I find my cursor, so let's suppose that matrix A was 2 by 3. Just making these numbers up. 2, 3, 6, -4, 0, 7. And matrix B was also 2 by 3. Marsh. Sorry, he's playing with his toy. Marsh, I love you. Stop it. Oh, you only gave me this toy. I got no other toy. I love you. He loves me. Cursor, where are you? There you are. 1, 3, I don't know. 12, 8, -4, and so if we wanted to find the new matrix whose name is A plus B, well, since A is 2 by 3 and B is 2 by 3, then A plus B is the name of the new matrix. That will be called, that will also be 2 by 3. All you do is you add corresponding entries. So the 1, 1 entry, the first row, first column, is a 2, and this 1, 1 entry is a 1. 2 plus 1 is 3. That's it. We just do that 5 more times. So 3 plus 3 is 6. 6 plus 12 is 18. -4 and 8 is 4. 0 and -4 is -4. And 7 and 2 is 9. All right. That's it. And then, as far as A minus B is concerned, just watch out for double negatives. That's all. So again, A and B are separately 2 by 3, so A minus B will be a 2 by 3. So 2 minus 1, 1, 3 minus 3, 0. And I'll just keep going. Oh, I did that right. I was worried. -12, +4, 5. All right, that's it. That's really all it is for adding and subtracting. Let's go to the videos. I'm sorry I did not load this up earlier. Don't worry, I know I'm touching my face, but I boiled my hands this morning, so they're clean. Alright, let me see. Clicky click. Alright, so if you would, please go watch video number 74, and then come on back. Okay. Scalar multiplication. So there's going to be two types of multiplication in this section. The first type is a scalar multiplication. A scalar is just fancy talk for a real number. That's all it is. So if you multiply a real number, k, by a matrix A, the result is called Ka. And all you do is multiply every entry of A by K. In other words, if I had the matrix A be 2, 3, 7, negative 2, negative 4, and I wanted to find 2A, then all I do is multiply 2 through matrix A. So 2 times 2 is 4, 2 times 3 is 6, 14, negative 8. That's it. That's scalar multiplication. Could not be easier. Now, you could pair scalar multiplication with addition and subtraction. So if you had two matrices like we did before, you could find like 3A minus 5B. You can probably almost guess what that is without even me doing an example. However, if you want to see an example, and you should want to see it, it'd be video number 75. So if you could watch 75, and then actually also 76. So video number 76 is just an application of all this stuff, because we're getting to the point of where would you ever use this stuff? Well, on the short scale, on the small scale of things, you probably wouldn't be doing stuff by hand. In real life, you would be doing stuff using a computer to calculate everything. Let's suppose that you managed a nursing home and you had to make sure that you had the right medicine for all of your patients. So you would probably have a matrix where the rows could be the patient's names and the columns could be the medicines necessary for that patient. And then if you found the sums of all these matrices, that would tell you how many of each drug you have to have available to order so that you satisfy the drug requirements for every patient. That's an example right there. So yeah, in real life, on the small scale, you're not working with a 1 by 4 like we have on the screen right now. You're probably working with like 100 by 1,000. But again, that's where the computer comes involved, and it'll do everything for you. Okay, so please watch videos, plural, 75 and 76. And believe it or not, that's really it for this section. It's just adding and subtracting a whole bunch. We leave multiplying and dividing for the next two sections. So watch those two, and then try the homework for 6-4, and then I'll also make some videos for 6-5, 6-6. Laters.